Yeah, so this week you'll need to cut something with your laser cutter to produce an object. So I will very briefly introduce what is this process. So one of the big advantage of laser cutting is that you can cut with high accuracy, and it's very versatile in terms of different materials. You can cut like cardboard, wood, some plastics, and even fabrics or food. It's not only able to cut, but it can also like raster images, so kind of print some images in like black and white, more or less. For example, on your wood, on your plastic. You can go. So the very basic principle is that there is a laser tube, for example, most probably in your laser filled with CO2. And this tube is emitting a beam that is light, that has one single wavelength, or one very narrow color, like one single color. And then this color, this beam of light is reflected through mirror and then focused by a lens on a very tiny spot in order to concentrate the energy, which enables it to burn or cut through your material. Next slide. So mainly you will use like 3 different processes. So as I just said, like cutting when you burn through the material, or engraving when your laser is following a specific path to like remove not the whole material, but just the surface. And rastering, which is like just burning the surface, and it's like the laser head is going back and forth, pretty much like a printing head when you print on paper. You can go to the next slide. The different settings that you'll need to consider for laser cutting is first the resolution of your image. So we'll work mostly between 300 and 600 dpi, which is the dots per inches. You will need to select the kind of job. So either like rastering, like for example, for images, or vector when you want to cut. And for rastering, you will have only 2 different settings, like the speed and the power. For a given power, for example, you will have to if you lower the speed, it will make the color a bit darker. And if you do like a vector pattern, like for example for cutting, you also need to consider the frequency, because when doing vector, the laser emits pulses, like many pulses per second, and this is the amount of pulse per second. And so for this, you need to understand like with which material you are working, and for this, for the parameters, you will, for example, ask your local instructor, or depending on your laser, maybe you have a manual that has a list of different material and which settings you need to use for each material. And if you don't know this, you can also like just experiment, just take like some random parameters and see if you need to increase or decrease the power, for example. Another thing that is important is to consider is the focus. So because you need to focus your the laser beam onto a small surface, there is an optimum distance between the laser head and your material. So you need to adjust this height either automatically on some laser, or you can also do it manually. Then the origin is just like the 0 point of your design on your stock material. And also never forget to turn on the pump. So usually you have 2 different pumps. One is blowing air like close to the laser head in order to remove the fumes that are produced by the burning process. And this is very important because when if the fumes would remain here, the laser could ignite them and it would be like very dangerous. And the other pump is used to vent out the fumes and to like push them to the filter. Okay, next slide, shall we, please? So as I said, there are many, like a range of materials that you can use. First, like wood is very versatile and it's cheap, so we often use this. You can use like plywood or MDF. You can also use acrylic, which is a kind of plastic. Be careful if you want to use other types of plastic, like some can be very dangerous to work with. For example, ABS is okay to 3D print with if you have the right setting. But if you want to laser cut ABS, don't do it because it's emitting like some cyanide gas. Uh, Another material which is very cool to cut is fabric. You can cut like, for example, cotton or felt, which are very um, easy to work with. Another good material to work with is paper or cardboard. Like we often even use like a recycled cardboard to make some simple construction, like some simple objects. You can also use different types of food, for example, pasta, or we tried like on the images below, we tried to raster an image on some traditional Armenian bread, which is like very flat, like paper. The image didn't come out like that well, but it's still an interesting effect. You can also, with a CO2 laser, so the one that you probably have, you can engrave glass. And with some other kind of laser, so you can engrave metal. We did like an astronomy project, but you need like a shorter wavelength rather than CO2, which is emitting infrared light. If you have a diode laser, which emits like a visible light, it's possible to engrave metal. And so just a few things to keep in mind when preparing for a laser cutter. You will need a vector graphics program, for example, Inkscape or Canva. And most probably, depending on your workflow, you will need to set all your lines to the line thickness to hairlines, because everything that is not hairline or 0.1 millimeter will be rastered. So kind of printed instead of cut. And like an image can be rastered. So now I will just show like a few different projects that can be used in a school setting. So if you want to teach handicraft, you can create looms. So either you can use it like, and many of these projects like for kids or with kids. So for example, you could make a bunch of looms to teach weaving, or you could even like create the looms with the students, and so that they have like, so that they make their tool and then use the tool so that they have an overview of the whole making process. Next one. In geography, popular project is to cut contour lines and to make 3D topographic maps. This can either be done also like with the students, or it can be a supportive material for a class. Like I was talking recently with a primary teacher, and she was complaining that her 8 years old kids didn't understand anything to topographic map lesson. And I was thinking, oh, if she would have like this kind of manipulative, it would have made the class much easier. Next slide. This is a project about history that we made in our lab a few months back, where a class came with their teacher, and they had the idea of creating a game, like a kind of quiz game. And if you answer the questions correctly, you would pick like some puzzle pieces and assemble the countries. And this is interesting because okay, sorry. Yeah, because go back to history. So maybe like while applying digital fabrication, they were not like mobilizing really like skills relevant to history. But as we just talked, like just collaborating and just the meaning that they were putting into this was making the whole project meaningful, like the digital fabrication process meaningful for this project. Okay, next one. A more obvious topic to use digital fabrication and laser cutting is, of course, physics. We had like a few, one group and one individual student who were studying mechanical advantages. So through either creating a pulley or a lever. And this is interesting because while designing and then creating their object, they would also need to mobilize physics related concepts. With biology, you can either create models, like this cell model was created by Susanna, who is also taking this class. It's not pure laser cut. It's also, there is also a bit of 3D printing, but you will see this in a bit. So you'll be able to make the whole cell soon. But you can also have your students. Yeah, you can also have your students like create, for example, hydroponic systems with the laser cutter, and then like learn about how to grow plants, aeroponic, hydroponics, etc. This project is the lesson plan for this one is available on ScopesDF. So if you want to take a look, it's already available. For languages, this is maybe less straightforward, but last year we had two English teachers, and they created like manipulatives for their students, and one of them was this grammar wheel that I think you already saw, where the students could practice WH question with this wheel.